we're going to talk about a new angle of measure, or new way of measuring angles, which is the gradient. Okay, so just as you can measure like the length of this desk, I could measure it in inches, or I could measure it in centimeters. I can measure angles using different units. Pre-calculus is kind of the place where we change from doing everything in degrees to doing things in radians. In calculus class, everything you do will be in radians. So we'll do kind of half and half because we're bridging over, okay? So I need to be able to change from one to the other. So the conversion that you have to remember is that pi radians are 180 degrees. So in question number 1A, it says, okay, so what's 100 degrees? Well, the easiest way to do this, you guys, is to remember that pi is the same as 180. These are the same. Pi radians is 180 degrees. So the question is, what then would equal 100 degrees? Does that make sense to you the way I set that up? I know that pi is the same as 180. So I'm trying to figure out what is the same as 100. So how would I solve that? How would I figure that out? Cross multiply. So 100 pi equals 180x. Just cross multiply. And then divide by, no, by 180 because we're trying to get x by itself. We want to get x by itself. Now, you almost always are going to be able to reduce these, and you need to reduce them. Clearly the zeros will cancel. So now I have 10 over 18, 5 ninths. So my answer is 5 pi over 9. Your radian measures will often have pi in them, but not always. I don't want you to think they always have pi. They don't, but they often do. So a whole pi is 180. Apparently 5 ninths of a pi is 100. That's what is 100. Okay, so let's do the next one. Negative 60. Pi is 180. That never changes. That's fact. Pi is 180. So what is negative 60? Does that make sense to you? So negative 60 pi equals 180x, cross multiply. The negative doesn't change anything about how you do the problem, you just have to have it. Then we're going to divide by 180. And again, the zeros are going to cancel, but what do we have? Now, how does that, what's 6 over 18? 1/3. So, my answer is negative 1 pi over 3. You don't need the 1, but if you want the 1 in there, you can. You don't need it, certainly. All right, Wyatt, I handed all these things out. You're responsible for hanging on to them. I'm not giving you extra copies. That's it. All right, last one in this section. What's your setup for problem C? What did you write down? Pi over 180 equals x over 210. So 180x equals 210 pi. And x equals 21 over 18. over 6. Everybody okay with that? Now, you're gonna love the next section, because it's even easier. Look at the first one. It says, now I have pi over 4 radians. And I want to know how many degrees that is. Well, now wait a second. What's pi radians?
180.
So if I had a whole pi, it would be 180. But I only have a fourth of a pi. So won't that be a fourth of 180? Which is something, we need to reduce that. Gotta get your calculators out, you're gonna need them anyhow here in a second. What's 180 divided by 4? What's 180 divided by 2? 90, and then divided by another 2 would be 45. So the answer is 45 degrees. Pi over 4 is 45 degrees. What, Jeff?
I was just out, but I got in my head. I was just gonna ask you to pi divided by square, divided by, and then multiply.
Just put 180 in for pi. A whole pi. A whole pi is 180. So let's look right here, guys. I'm doing the next problem. A whole pi is 180. What's a third of that? What's a third of 180? 60. But I have 2 of those. So that would be 120. That's 120 degrees. Pi is 180. Divided by 3 would be 60. Times 2 is 120. You can also times by 2 first and then divide, whatever's easiest for you. Negative pi over 6. Negative pi over 6. Well, what's pi? 180. Negative pi then would be negative 180 divided by 6. What's negative 180 divided by 6? Yeah, negative 3. All right, here we go. What's pi? What's a whole pi? 180. What's a sixth of that? What's 180 divided by 6? 30. And now I need to multiply that by 7. 7 times 30 is 210. Now, E is harder. What's wrong with E? There's no pi. So as long as there's a pi, I've just been putting in 180s there and everything's been fine, and that's the way I want you to do it. But if there's no pi, we have to go back to that ratio we were using before. Pi is the same as 180. So what is the same as 2? Now, how come in problem 1a, when it was 100 degrees, I set up my pi over 180 and said x over 100? Because it was a degree. That was a degree. And in this fraction, which of these is the degree number? 180. So in here, pi radians is 180 degrees. That's 2 radians, so it has to go on the top where the radian number goes. This is the degree number. So do you see the difference? Why the x is on top here, but it's on the bottom here? This is radians, this is degrees. So whichever one you're given, that's where you put it. So this is 2 radians, so it goes on top. So pi times x is 360, 2 times 180. So x equals 360 divided by pi. And that's my answer. We don't change it, don't change it, leave it, 360 divided by pi. Okay? And then F is a no-brainer. Pi radians is how many degrees? 180, that's 180. Pi radians is 180. Okay. Now, we're going to look at changing, this is called a decimal degree, 100.4 degrees. It's a decimal degree. You know how, like, if you have a regular clock, the hour is divided up into 60 pieces called minutes, and then minutes are divided up into 60 pieces called seconds. The same actually works for degrees. So a degree can be divided up into 60 smaller pieces called minutes. And then a minute can be divided up into 60 smaller pieces called seconds. So instead of using a decimal degree, we could say this is 100 whole degrees and then some minutes. In the old days, we used to have to figure all that out by hand. You are lucky because your calculator does it for you, okay? So here's what I want you to do. I want you to type 100.4. And then I need you to find the angle button. It's a blue, so we're gonna need a second. It's a blue, and it's right here where my fingernail is. You see where it says angle on your calculator? Okay, so press second angle. And then go down, oh shoot. And then go down to where it says DMS. Guess what DMS stands for? Degrees, minutes, seconds. So you just press enter, and it tells you that 100.4 degrees is 100 whole degrees, which you knew. 24 minutes, that's the minute notation, and 0 seconds. Just again, another way of saying partial degrees. We can use a decimal, that's called a decimal degree, or we can do minutes and seconds. Okay, so let's try the next one. 18.375, and then second angle DMS. What did you get for that one? 18 degrees, 22 minutes, and 30 seconds. And then the last one, and again, the negative doesn't impact anything, you just have to have it. So, negative 20.42, second angle DMS. What did you get for that one? Negative 20 degrees for sure. What did you get? 25 minutes and 12 seconds. Now, we're going to use our calculators to do the opposite. So if you look at number 4, it says we have 132 degrees, 11 minutes. And we want to change that into a decimal. So we want to do the opposite here. We're going to go back to the decimal form. So it's really easy. Go ahead and type in 132. And then if you go to second angle, where you were before, what is option number 1? Press it, that's your degree. So now you told the calculator 132 degrees. Now press 11, and if you go back into second angle, what's the second option? Minutes. Press that one, and then enter, and you get 132.183 degrees. So if you have the degrees and minutes, then when you type it in on the calculator, you have to put in the degree and the minute symbol. All right, let's try the next one. 18. Phoebe, you typing with me? Second angle, degree. 12, second angle, minute. 13, second angle. Crap. I don't have a second mark, do you? Actually, you do, and you're not gonna believe where it is. All right, so second quit, get out of that, just hit second quit. Look at your plus sign. And right above your plus sign in green is the second mark. So you need to press alpha, that's your green button, plus, and that puts in your second mark. Now why is it there? No clue, no clue, but it's there. Press enter, and that one is 18.2036 degrees, is that what you got? So where do we get the seconds? If we have to put in a seconds, we go to alpha plus. All right, last one. Try this one all by yourself, see if you can get it all typed in. All right, everybody get this one? Now, do me a favor real quick, because you're gonna need to remember this in a long time from now, when we get back to this, we're only doing 4-1, so, before Christmas. So, make a couple of notes and remind yourself how you put these into the calculator. How did you put this into the calculator? You type -152, second angle degree, whatever the next number was, second angle minutes, and then your seconds number, alpha plus. Just so you can remember that, because right now it seems really easy, and it is really easy, but you might forget. Okay, so let's talk a little bit about this next section, which is kind of a pretty main piece of the section. S indicates, that's an S, indicates the arc length. And by arc length, we just mean this right here. How long is that arc right there? Little arc. R, of course, stands for the radius, and theta stands for the central angle. This is a theta, that is a Greek letter. We use a lot of Greek letters in trigonometry because they're the ones that kind of started working on all this stuff. So that's a theta, it's like an X, It's a variable. It just happens to be in another language, but it's the unknown angle. Here's the thing you gotta remember though. This angle must be in radians. So if it's not in radians to start with, guess what you're gonna have to do? Change it to radians like we did. That's what the very first thing we did. When we say pi over 180 equals x over whatever. So these can be two-step problems. Let's look at the first one. The first one says, I know that my radius is 10, my angle is 2, and I want to know my arc length. Now, one little kind of important thing I didn't tell you is that when angles are measured in radians, there's no unit. So, if I want to talk about this angle being 80 degrees, I put a degree mark on it. But if there's no degree mark on it, then that angle is in radians. So this is a radian measure. So what's my arc length? Radius times radians. That's how I think of this, radians times radius. So that's going to be 20. The answer to the problem is simply 20. If this were 10 inches, which I don't know what it is because I didn't put anything in there, but if it's 10 inches, then this would be 20 inches. Arc length is like a length. Okay, Aubrey, you okay today? All right, let's look at the next one. The next one says the angle is 1.5. Notice no degree mark, so that's a radian. That's good. That's good. That's what I want, a radian. The arc length is 6, and I have to find my radius. What do you think I'm going to do? Yeah, my formula says 1.5 times r equals s. 1.5 times r equals s. So what's my r? 4. And again, if this had been 6 feet, then r would be 4 feet. They're the same unit, the radius and the arc length. All right, how about this one? Arc length is 10, radius is 4, and I want to know my angle. So what does your formula say? Arc length equals the angle times the radius. Oh, what was my radius?
4.
So what's my angle?
2.5.
5 over 2, 2.5. And that would be 2.5 what's? Radians. Because every time you use this formula, theta, the angle, is in radians.
Oh, sorry.
Go ahead.
Do you write radians?
You don't have to. Because remember, no label automatically tells you it's radians. If you wrote radians, it wouldn't be wrong, but you don't have to. What was it? Okay, D. Degrees, the radius is 10, and the arc length is, we don't know. Here's the formula. Oh, I know what I was going to say. If you don't like using theta, you can call that x. It's just like algebra class. The variable doesn't really matter. Just remember, though, that what do we know about theta? It has to be in radians. So you can't use 30. Because that's a degree. So the first thing we have to do is change that into radians. So go back to the very first thing we did today. Pi is 180. And make another fraction. So pi over 180, that never changes. That stays the same. What am I gonna put over here? X over
30.
bingo. Because we are changing 30 into a radian. 180 goes with pi. We're figuring out what goes with 30. So 30 pi equals 180x. Okay, the zeros cancel. What's 3 over 18? Pi over 6. So this angle is pi over 6. That's not the answer to the question. The answer to the question is, what's the arc length? How do you find the arc length? You take your angle times your radius. So we take pi over 6 times 10 over 1. Pi over 6 times my radius, which is going to be 10 pi over 6, multiply straight across, which is going to reduce to what?
5 pi over 3.
5 pi over 3. There it is. That is 2 steps because the angle was given to you in the wrong form. You have to have it in radians. To do this problem, to find that arc length, you need your angle in radians. All right, one more. What do I know this time? I know that's 90 degrees. I know my arc length is 10 pi, and I want to know my radius. Now, here's your formula. It's a very simple formula. Arc length equals radius times radians. Very simple formula, but what's the matter? The angle is in degrees, and it needs to be in radians. So, this is not the answer to the question, but over to the side, I've got to figure out how many radians that is. So what's my setup? Pi over 180 equals x over 90. This never changes. Never mess with this. This is the equality here. Pi is 180 in terms of radians and degrees. So 180x equals 90 pi. So it looks like x equals 90 pi over 180. What does that reduce to?
Pi over 2.
Pi over 2. 1/2 pi or pi over 2. Now there will be kids who get excited about doing that and doing it correctly, and they'll put that in the answer blank. That isn't the answer. All we've done is fix our angle so it's usable. Now we go back to our formula. Arc length equals angle times radius. So here's what I've got. My arc length is 10 pi. My angle is 1/2 pi times my radius. Okay, we're over our feared fractions. We're going to get rid of it, so we're going to times by 2. So 20 pi equals pi r. I'm timesing by 2 to make that go away. And then how will I get r by itself? Divide by pi. So what does r end up equaling? 20.
Oh, does pi cancel pi?
Mm-hmm. Yeah. Pi's just a number. Okay? All right. Now, we don't have our textbook compass. So I'm gonna draw one up here for you, and you might wanna sketch it somewhere if you got room or on another sheet of paper. You all know what I mean by compass? Like if you're out in the woods and you're lost, you get out your compass. And what do you know about the directions, north, south, east, west? Where are they on the compass? North is up, south is down, east is over here, and west is over here. Perfect. Perfect. Now, this is a full revolution, so in terms of degrees, it would be 360 degrees all the way around. In navigation, so using a compass, due north is considered 0, which automatically means what's due south then? 180. And east is 90. And south, or excuse me, west is 270. Okay, so far so good. Now, obviously, when we move out in the forest, we don't move just in these directions. We can move diagonally. So what would that green one be called, do you think? Well, it would be 45 degrees, and it would be called northeast. Because it is halfway between north and east, and it would be 45 degrees. What about this one? What do you think this one's called? Southeast. And what would its degree measure be? Figure it out. 135. Because isn't it 90 plus another 45? Right? How about this guy? What's he? Southwest. And what would be his degree measure? Remember, we're going this way. So here's 180, and then another 45, 225. And then this guy would be northwest, and he's 270, and another 45, 315. And then, of course, if we went all the way around, we could actually, no one ever does this, but you could actually call north 360, but we don't, we call it 0. Okay, well, we're going to subdivide one more time. We're going to draw this one in, and that is splitting the 45. So each of these little pieces here would be 22 and a half. Would you agree with that? Because I split the 45. And I could do the same thing here. And these would be 22 and a halves also. Now, I'm not going to do this, I'm not going to label all those all the way around. But every time I split my 45, when I split my 90s, I got 45s. When I split my 45s, I'm getting 22 and a halves. This one, anybody know what this one's called? It's called north-northeast. This one is called east-northeast. Now, let's talk about that. This is the northeast line, right? This split is on the north side of northeast. This split is on the east side of northeast. So that's why that one's called north-northeast, and this one is called east-northeast. What do you think this one's called? East-southeast. Very, very good. Because it's on the east side of the southeast diagonal. And then this one would be southeast. Yep, the south side of the southeast. And so on and so on and so on all the way around. All right, so let's answer the questions. Find the angle measure that describes east, southeast. So here's east, southeast. We already have that one labeled. So remember, we started here at 0. So going to east would be 90. And then how much extra are we going? 22 and a half. So wouldn't that be 112 and a half? Remember, all these little splits are 22s and a halves because we split a 45. The green lines split a 90, so they're 45s. The blue lines split 45, so it's 22 and a half. Southwest, well, I happen to have that one already done too. Southwest is just 225. Ooh, west, northwest. Now, here's northwest. I'm going to subdivide. Am I going to subdivide on the bottom or the top if I want west, northwest? Bottom. Because this is the west side of the northwest line. This is west, northwest. What's the angle measure for due west? 270. How much more am I going? I'm going another 22 and a half. So what's the west northwest label? 292.5 degrees. Yep, that's exactly right. And then north northwest. Well, wouldn't that be this one? Again, here's the northwest line. This is the north split of that. What's that angle measure? 337.5. And how did you get that, Jared? Because there's a couple different ways you can do it. So Jared took 315, which is northwest, and added 22 and a half. Did anybody think of doing 360 minus 22 and a half? That would work also. All the way around 360. You're going to use that to do some problems later on in the chapter. And we're going to use it right now. We have one more quick problem to do, and maybe we can look at some homework. You are going to draw a sketch of the journey. You're not doing any math. You are simply drawing a sketch of the journey. Okay, so here's my compass. I'm not going to make a circle, I'm just going to set it up. Here's my north, south, east, west. And I know this is 0 and 180 and 90 and 270. So what's my ship doing? He leaves port, here's port, and he travels 15 miles on a course of 100 degrees. Where is 100 degrees in this framework?
In southeast.
Wouldn't it be down here somewhere? So this is 100 degrees. And that's exactly how I want you to label it, just like that. And he went 15 miles. So the length of that vector right there is 15 miles. Okay, so now he's sitting right here. Would you agree with me? He's traveled his 15 miles. Now he's sitting right there. So I'm going to set up a new compass. And what's he going to do now? He's going to go on a course of 200 degrees. Now remember, this is 0, this is 180. Where's 200 going to be? Isn't 200 going to be right here? So So label that 200. Always start at 0 and come around. That's how we measure. And how far did he go that time? Oh, he only went 2 miles. So I'm gonna shorten that up. Because if that was 15, this would be 2, approximately. So now my ship is sitting right here, and we're done at this point. By the end of this unit, here's what the problem's gonna say. This ship did this and this and this, and then his engine stopped and he sent out a distress call. So you're gonna figure out the rescue plane is at port. You're gonna figure out what direction and distance that plane has to fly to rescue these stranded sailors. It is so cool. That's what trigonometry is all about. All right, let's get your homework. And let's get that first homework assignment at least started for you. And we are not losing any of this paperwork. All right, so here we go. Changing the radians. Who remembers how to do this? We're going to change this into radians. What's our setup? Pi over 180 equals x over 165. So 180x cross multiplying equals 165 pi. Right? And then we'll divide. Now, there's no zeros to cancel here, but 165 and 180 are clearly both divisible by 5. Mackenzie, that's not divisible by 2.
I don't know. I don't understand.
Okay, so what's 5 into those guys? What is that? 33 over 36. Oh gosh, those are divisible by 3. So my final answer is going to be 11 pi over 12. Okay, easy. All right, change into degrees. Well, the first one's super simple because what's pi?
180.
So this is 11/6 pi, but pi is 180. 180 divided by 6 is 30, and 30 times 11 is 330. Now, if you have a calculator, you can just type in 11 times 180 divided by 6. If you don't have a calculator, you might consider doing the way I do it there because it's easy arithmetic. But not B. B is not easy arithmetic.
So pi over 180 equals x. Oh, no, 3 over x.
3 over x, that's exactly right, Jack. That's exactly what it would be. There's no pi in this problem, so I have to go back to the same little proportion I used before. Pi radians, 180 degrees, never changes. 3 radians, how many degrees? So pi x equals 540 when I cross multiply, and x equals 540 over pi. If the pi is in the problem, you can go ahead and make it 180. But if the pi isn't in the problem, you just leave it. Okay, that's part of your answer. All right, degrees, minutes, seconds, here we go. 172.373. Second angle DMS. 172 degrees, 22 minutes, and 22.8 seconds. Is that what you got? How do you change into degrees, minutes, seconds? You use your DMS button. And then, what if you have degrees, minutes, seconds? Well, 202, second angle degree mark, 13, second angle minute mark, and here comes a tricky one, 19 alpha plus, and I got 202.2219 degrees. All right, we can do 5A for sure. The radius is 6. The arc length is 10 inches. The radius is 6 inches. And our job is to find the angle. I erased it, but my formula is arc length equals radius times radians, or in terms of letters, S equals R theta. Doesn't matter to me how you remember it, you gotta remember it. So 10 equals 6 theta, and theta equals 10 over 6, which reduces to 5 over 3. Done. Now it's done. So that homework will be due on Wednesday. This is the last, we're not going to cover any more of those. Starting Wednesday, we will start a real exam review on Wednesday. Okay? Do not lose any of the papers that I gave you.